According to UL 508 2018 edition, specifically section 43.8b, a requirement exists for grounding the direct current power supply common. This means that within the scope of UL 508, which covers industrial control panels and related equipment, the common or negative terminal of the direct current power supply must be connected to ground. This requirement is significant for several reasons related to safety and proper function of the equipment. Grounding the direct current power supply offers protection against electrical shock. In the event of a fault where a live conductor comes into contact with the enclosure or other conductive parts, the grounded direct current system provides a low impedance path for fault current to flow. This high current flow will quickly trip a circuit breaker or blow a fuse, disconnecting the power and preventing a dangerous voltage from being present on the enclosure, thereby mitigating the risk of electric shock to personnel. Grounding helps to reduce electrical noise and interference. Electrical noise can disrupt the operation of sensitive electronic components and cause malfunctions. By providing a stable ground reference, the direct current grounding system helps to minimize noise and interference, ensuring reliable operation of the equipment. Furthermore, grounding protects against electrostatic discharge, commonly known as ESD. Static electricity can build up on objects and people, and a sudden discharge of this static electricity can damage sensitive electronic components. Grounding provides a path for static charges to dissipate safely, preventing damage to equipment. It is crucial to understand the difference between UL 508 and the National Electrical Code, also known as NEC, Article 250. While the NEC provides comprehensive requirements for grounding and bonding of electrical systems, UL 508 is a product safety standard specifically for industrial control panels. The NEC may not always require grounding of direct current power supplies under 50 volts, as stated in Article 250. However, UL 508 imposes additional requirements to ensure the safety and proper functioning of control panels, which often operate in industrial environments with more stringent safety demands. To comply with UL 508, one must adhere to section 43.8b, which mandates grounding of the direct current power supply common. This grounding connection must be made in accordance with the requirements specified in UL 508, which include using appropriate grounding conductors and termination methods. The grounding conductor must be sized adequately to handle the maximum fault current that could flow in the event of a fault. Typically, the size of the grounding conductor is determined based on the size of the overcurrent protection device protecting the direct current power supply. The grounding conductor should be connected to the main grounding electrode system of the building, ensuring a solid and reliable ground connection. It is also important to ensure that all metal enclosures and conductive parts of the control panel are properly bonded together and connected to the grounding system. This bonding helps to create an equipotential plane, minimizing voltage differences between different parts of the equipment and reducing the risk of electric shock. When designing and installing industrial control panels, it is imperative to consult the latest edition of UL 508 and follow all applicable requirements. This includes verifying that the direct current power supply is properly grounded, that all grounding and bonding connections are made correctly, and that the equipment meets all other safety requirements specified in the standard. Failure to comply with UL 508 can result in serious consequences, including equipment damage, personal injury, and legal liability. Therefore, it is crucial to prioritize safety and ensure that all electrical work is performed by qualified personnel who are familiar with UL 508 and other applicable codes and standards. The purpose of grounding a direct current power supply, as mandated by UL 508 section 43.8b, is multifaceted. Firstly, personal safety is paramount. Grounding creates a low impedance path for fault currents. If a live conductor accidentally contacts the metal chassis or enclosure of the control panel, this low impedance path ensures a large fault current flows. This high current will quickly trip the overcurrent protection device, such as a circuit breaker or fuse, disconnecting the power supply and preventing a hazardous voltage from remaining on the enclosure. Without proper grounding, the enclosure could become energized at a dangerous voltage, posing a significant electrocution risk to anyone who touches it. Secondly, equipment protection is enhanced through grounding. Grounding provides a stable reference point for the direct current power supply and the connected circuitry. This helps to minimize voltage fluctuations and electrical noise, which can damage sensitive electronic components. Moreover, grounding provides a path for static electricity to discharge safely. Electrostatic discharge can damage or destroy electronic components, leading to equipment failure. By providing a path to ground, static charges are safely dissipated, preventing damage. Thirdly, improved system performance is achieved through grounding. Grounding reduces electrical noise and interference. Electrical noise can interfere with the operation of sensitive electronic components, causing malfunctions and unreliable operation. By providing a stable ground reference, the grounding system helps to minimize noise and interference, ensuring reliable operation of the equipment. To reiterate, the specific requirement in UL 508 2018 edition section 43.8b mandates the grounding of the direct current power supply common. The grounding must adhere to UL 508 guidelines, which detail the appropriate grounding conductor sizes and termination methods. The grounding conductor size must be sufficient to handle the anticipated fault current, usually determined by the overcurrent protection device's rating. The grounding conductor must connect to the building's main grounding electrode system, guaranteeing a dependable grounding connection. Bonding all metal enclosures and conductive parts of the control panel to the grounding system is essential. This creates an equipotential plane, minimizing voltage differences across the equipment and reducing the risk of electric shock. Proper implementation of the UL 508 grounding requirements necessitates consulting the standard's latest edition. This includes verifying proper direct current power supply grounding, ensuring accurate grounding and bonding connections, and meeting all other safety standards within UL 508. Neglecting UL 508 compliance can lead to severe consequences, including equipment damage, injuries, and potential legal issues. Safety must be prioritized, with qualified personnel performing all electrical work, knowledgeable in UL 508 and other relevant codes. Consider a scenario where a control panel is used to operate a motor. The direct current power supply within the control panel provides power to the motor control circuitry. If the direct current power supply is not grounded according to UL 508, a fault in a motor or its wiring could cause the metal enclosure of the control panel to become energized. This energized enclosure would pose a serious shock hazard to anyone who touches it. However, if the direct current power supply is properly grounded, the fault current would flow through the grounding conductor, tripping the circuit breaker and energizing the control panel. This would prevent the enclosure from becoming energized and protect personnel from electric shock. In another scenario, consider a control panel used in a sensitive electronic manufacturing process. The direct current power supply in this panel provides power to delicate electronic components. Without proper grounding, electrical noise and static electricity could disrupt the operation of these components, leading to process errors and equipment damage. However, with proper grounding, electrical noise is minimized and static electricity is safely dissipated, ensuring reliable operation of the equipment and preventing costly damage. Grounding is not merely an afterthought, it is an integral part of the design and installation of industrial control panels. It provides essential protection against electrical shock, reduces electrical noise, and improves system performance. By adhering to UL 508 grounding requirements, we can ensure the safety and reliability of electrical equipment and protect personnel from harm. It is essential to remember that UL 508 is a product safety standard, while the NEC is an installation code. UL 508 specifies the requirements for the design and construction of industrial control panels, while the NEC specifies the requirements for the installation of electrical equipment and systems. In some cases, the requirements of UL 508 may be more stringent than the requirements of the NEC. For example, UL 508 may require grounding of direct current power supplies even if the NEC does not. This is because UL 508 is specifically concerned with the safety of the control panel itself, while the NEC is concerned with the safety of the entire electrical system. When designing and installing industrial control panels, it is essential to comply with both UL 508 and the NEC. This will ensure that the equipment is safe and reliable, and that it meets all applicable codes and standards. The grounding conductor should be green or green with a yellow stripe according to electrical codes. This color coding helps to easily identify the grounding conductor and prevent it from being mistaken for a live conductor. The grounding conductor should be installed in a manner that protects it from physical damage. It should be routed along a path that is separate from live conductors, and it should be securely fastened to the enclosure and the grounding electrode system. The grounding electrode system should consist of one or more grounding electrodes that are connected to the earth. The grounding electrodes should be made of a conductive material such as copper or steel, and they should be buried in the earth to a depth that ensures good electrical contact. The grounding electrode system should be designed to provide a low impedance path to ground. This will help to ensure that fault currents flow quickly and safely to ground, tripping the circuit breaker and energizing the equipment. Regular inspection and testing of the grounding system is essential to ensure that it is functioning properly. The grounding connections should be checked for tightness and corrosion, and the grounding electrodes should be tested to ensure that they are providing a low impedance path to ground. If any problems are found, they should be corrected immediately to prevent electrical hazards. In summary, grounding the direct current power supply common in UL 508 listed industrial control panels is a critical safety measure. It protects against electric shock, reduces electrical noise, and improves system performance. By adhering to the requirements of UL 508 and the NEC, we can ensure the safety and reliability of electrical equipment and protect personnel from harm. Remember to always consult the latest editions of these standards and seek guidance from qualified electrical professionals when designing and installing electrical systems.